Now say next question from exercise 1.1. Question number 14. Evaluate I raised to the power 37 plus 1 upon I raised to the power 67. So we first split up the given power. So we write this I raised to the power 37 as I raised to the power 36 I raised to the power 1. And this I raised to the power 36 we write in the multiple of 4. So 4 9s are 36. I raised to the power 1 is I. So we write this as I raised to the power 4 raised to the power 9 into I. I raised to the power is 4 is 1. So 1 raised to the power 9 into I, which is equals to 1 into I, which is I. So first we find the value of I raised to the power 37. Then we find the value of I raised to the power 67. This I raised to the power 67 can be written as, so we write here I raised to the power. So when we divide this 67 by 4, so we get here 16 4s are 64. So we write here 4 into 16 and the remainder is 3. So we write I raised to the power 3. So we write here I raised to the power 4 raised to the power 16. I cube is minus I. So we write this as 1 raised to the power 16 into minus I. So we get 1 into minus I, which is equals to minus I. Now we reduce the power. Now we substitute this value to which part we have to evaluate. So we substitute I raised to the power 37. We calculate that as I. So we write here I plus 1 upon this I raised to the power 67. We reduce to minus I. So write here minus I. This is equals to I. So plus minus get minus. So we write 1 upon I. So now you can cross multiply. So if we cross multiply this, we get here I square minus 1 upon I. So I square is minus 1. So we write here minus 1 upon I, which is equals to minus 2 upon I. Now we have to reduce this. We have to eliminate this denominator I because we write in the form of a plus ib. So for next we multiply and divide by minus I or now say question number 15. 1 plus I bracket raised to the power 4 into 1 plus 1 upon I bracket raised to the power equals to 16. So we have to show here LHS equals to RHS. So here we first consider LHS. LHS is equals to 1 plus I raised to the power 4 into 1 plus 1 upon I raised to the power 4. So we first simplify this second bracket. So 1 plus I raised to the power 4 into, if we cross multiply this, we get I plus 1 upon I raised to the power 4. Now we separate the base. 1 plus I raised to the power 4. This I plus 1 can be written as 1 plus I. So we write 1 plus I raised to the power 4 upon this denominator, that is I raised to the power 4. Now we know that I raised to the power 4 is 1. So we get in numerator 1 plus I raised to the power 4 into 1 plus I raised to the power 4. So we write 8 square upon I raised to the power 4 as 1. So we interchange this power. So if we interchange this power, we can write 1 plus I raised to the power 2 raised to the power 4 upon 1 So here we cannot write that one. Now we have to apply the formula a plus b bracket square here. Then we take it power 4, which will be convenient for us. Instead of calculating the value of a plus b bracket raised to the power 4, so we interchange this power, because we know that a raised to the power m into n can be written as a raised to the power n into m. So we can write a raised to the power n bracket raised to the power m, or a raised to the power m bracket raised to the power n. We write in this form. So we can interchange that power. So we use the formula a plus b bracket square. So we write now see next question. Question number 16. Find the value of I raised to the power 16 plus I raised to the power 7 plus I raised to the power 8 plus I raised to the power 9 upon I square plus I cube. So we write in solution I raised to the power 6 plus I raised to the power 7 plus I raised to the power 8 plus I raised to the power 9 upon I square plus I cube. Now reduce the power in power 1, 2, 3 or 4. So I raised to the power 6 we reduce as I raised to the power 4 into I raised to the power 2, because I raised to the power 4 is 1. So we reduce that I raised to the power 6 as I raised to the power 2. I raised to the power 7 as I raised to the power 4 into I raised to the power 3 plus I raised to the power 8 as I raised to the power 4 into I raised to the power 4 plus I raised to the power 9 as I raised to the power 4 into I raised to the power 4 into I upon I square in plus I cube as it is. Now substitute the values. So this I raised to the power 4 is 1, I square is minus 1, I raised to the power 4 is 1, I cube is minus I raised to the power 4 is 1, 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 I as it is upon I square is minus 1, I cube is minus I. So write this as 1 into minus 1 is minus 1 plus minus minus, so we get here minus I. Then now say question number 17. If A equals to minus 1 plus root 3i upon 2, B equals to minus 1 minus root 3i upon 2, show that A square equals to B and B square equals to A. So we write here in solution, we first show A square equals to B here. So we have to consider LHS of A square equals to B. First, we show a square equals to b. Therefore we have to write, therefore LHS is equals to a square is equals to, now substitute the value of a as -1 plus root 3i upon 2 its square. So we first separate the square of numerator, separate the square of denominator. So we write here -1 plus root 3i its square upon 2 square. Now instead of writing -1 plus root 3i, we write plus term first, minus term at second position, so which will be convenient for calculating the value. So upon 2 square we write as 1/4 and write this as root 3i minus 1 its square. So we use the formula a minus b bracket square. So 1/4 in bracket we write root 3i its square, that is a square minus 2 into a is root 3i into b is 1 plus b square means 1 square. So make the square of both terms. So we write here 1/4, square of root 3 is 3, square of I is I square minus 2 root 3i, square of 1 is 1. So calculate this, which is equals to 1/4 in bracket 3 into I square is -1 plus 2 root 3i plus 1 as it is. So we write here 1/4 in bracket 3 into -1 is -3 plus 2 root 3i plus 1, 1/4 in bracket -3 plus 1, so we get -2. So we first write the plus term. Now say question number 18. If x plus iy equals to a plus ib its cube, show that x by a plus y by b equals to 4 times a square minus b square. So we consider given part here. Given part is x plus iy is equals to a plus ib its cube. So we write the cube of RHS first, then by equality of complex number we find the value of x by a, y by b. So see here, we keep LHS as it is x plus iy equals to. Now apply the formula of a plus b bracket cube. So a plus b bracket cube is a cube plus thrice a square b plus thrice a b square plus b cube. Now here in place of a value is a, in place of b value is ib. So we have to write this as a cube plus thrice a into. So if we take square of a, then we have to take ib as power 1 plus thrice a ib as power 2, then ib its cube. So write a cube plus thrice a square bi, then plus thrice a. Now square of I, square of b, so we write I square b square plus square cube of I, cube of b, so we write I cube b cube. Here a cube plus thrice a square b, I square is minus 1, so we write I square as minus 1, so its sign changes, so we write minus 3a b square. Then I cube is minus I, so we write minus b cube into I cube is minus 1, sorry, I cube is minus I, so plus minus minus, we write b cube first, then I. Now take a real and imaginary part separate, so a cube minus 3ab square as a real part, so we write that in one bracket, plus here is I, so take I common, so we write 3a square b minus b cube into I. So we equate a real part with real part, imaginary part with imaginary part. So right here, by equality of complex number, x is equals to, so we write real part as x is equals to a cube minus thrice ab square, then y equals to imaginary part 3a square b minus b cube. So from this we can take a common, so we write x is equals to a in bracket a square minus 3b square. Here we write y is equal to, if we take b common, b in bracket 3a square minus b square. So from this we can write x by a equals to, so when we take a to left hand side, we write x by a equals to a square minus 3b square. When we take b to left hand side, we write y by b is equals to 3a square minus b square. Now we have to show here x by a plus y by b equals to 4 times a square minus b square. That means we have to add this x by a with y by b. So we write here, therefore LHS is equals to x by a plus y by b. So we substitute the value of x by a as a square minus 3b square. So we write here a square minus 3b square. Then y by b as 3a square minus b square. Now see the like terms, a square plus 3a square, so we get 4 times a square minus 3b square minus b square, so we get minus 4 times b square. So taking 4 common, we write a square minus b square, which is equal to RHS. So in this way we show x by a plus y by b is equal to 4 times a square minus b square.